Okay, question 22 is a Venn diagram question. It says a Venn diagram shows information about coin collection. We know there's 120 coins in the collection. T, which is this region here, represents coins from the 20th century, and B represents British coins. Okay, and the bit in the middle represents both coins that are from the 20th century and are British, as they overlap. We've got this value here, 32, and what that refers to is the number of coins that don't fit into either of these categories. So they are not British and they're not from the 20th century. We're told that a coin is chosen at random. It is British. Work out the probability that it's from the 20th century. Okay, so in terms of our first steps, we need to first of all work out what all the probability will add up to. Okay, so we can see that by adding up these three parts will tell us the number of coins that are from the 20th century and British, and also the number of coins that aren't either of those. So we need to add up all of this. So I'm going to write x brackets x minus 15, add x, which is the intersection here, plus x minus 2, plus 32, and we know in total that there were 120 coins, so it should equal 120. Now, expanding this out, I'm going to get x squared minus 15x. Simplify that bit, we get plus 2x, minus 2 add 32, but that's plus 30. And we can now just simplify this again, so we've got minus 15x plus 2x, so minus 15 add 2 is minus 13, so I get x squared minus 13x plus 30 equals 120. Now, the idea of doing all of this is, remember x just stands for a number, and it refers to the number of coins. So what we're trying to do really is work out what x is, because then that can help us work out how many coins are in each of these parts, and then we can start working out whether what the probability is. So we're trying to work out what x is. So because we've got x squared, if we make it equal to 0, we could perhaps factorise it, and then that can tell us what x is. So I'm going to take away 120 from both sides. So 30 take away 120 is minus 90. So I get x squared minus 13x minus 90 equals 0. And when I'm factorising, I'm looking for two numbers that multiply to give the number on the end, but they have to add to make 13. So I'm going to write out a list of ways of doing that. So 1 times 90, 2 times 45, 3 times 30, 4 times, I don't think will work, 5 times, 10 times 9 makes 90, so 5 times 18 will work. You have got your calculators if you need it. Okay, so I'm going to continue on like that. Let's have a look. Can we see a pair of numbers that would make 13 potentially? So for example 5 and 18 I can see would make 13. So I'm going to use those values, and actually we don't want 13, we want minus 13. So we need to think carefully about what signs these are going to be. So if I have minus 18 and I add 5, then minus 18 add 5 gives me minus 13. So I know I want my signs this way round. So when I'm factorising, I'm going to put these into brackets. I'm going to have x and x to give me the x squared, and I want to have plus 5 and minus 18. So those are my values in the brackets. Now what this means is that in order to solve it, I have to do the inverse. So x is either going to be minus 5 or x is going to be 18. So I'm going to write that down, x equals minus 5 or x equals 18. So if we just think about this, x stands for a number, alright? And we've got x on its own here. We can't have minus 5 coins in the middle, because that would be a load of rubbish. So I'm going to cross that one out, and that is a value I'm actually going to use. Okay, so you have to think about the context of the question. Could you actually have that? No, so it's going to be this. So I now know that x is going to be 18. So what I'm going to do is change that. So instead of x is going to be 18, instead of x minus 2, 18 minus 2 is 16. Now this bit, we know x is 18. We might as well put this into the calculator so I don't make any mistakes. I'm going to do 18 brackets. That's 18, so it's 18 minus 15. And I get 54. So I know that this evaluates to 54. Okay. And another thing you can do to check is that all these values should add up to the total, which we saw in the question was 120. So let's just check that. So 54, add 18, add 16, add 32, and that does indeed come to 120. So we know we've done this right. So we're in the on the right road now to be able to work out the answer. It says work out the probability, so I want a fraction that is from the 20th century, and the key bit, I almost missed it, was it is British. So coin is chosen at random, it is British. So that means that it has to be out of one of these values in this circle. So if I add up these two values, that gives me 34. That means my probability has to be out of 34, not out of 120, because out of 120 is if it just said a coin is chosen at random. It could be any of these coins, but we're specifically told that it's British, so it's got to be somewhere within this, so it's got to be out of 34. So actually, before I go any further, I'm going to write out of 34 so I don't make any mistakes, and it says work out the probability that it's from the 20th century. So remember, that's the T part here, so T is the coins from the 20th century. The T is this region. The only value that is within both of these, so is British and is part of T, is this 18. So I know it's going to be 18 out of 34. We just check with the mark scheme as to what they wanted to see. So we can see that the first part of the question is how we started it. So by adding up all the values, making it equal to 120 to help us work out what x is, that gives us the first mark. We get down to the point where we've simplified it, we've got it equal to 0, that gives us a second mark. If we've then factorised it correctly, then we get the third mark. It actually gives you some other options. So if you written brackets where the a times b gives you minus 90, and a plus b gives you minus 13, then you can get the mark for that as well. The next bit is to get the 34, so that's the bottom of the fraction bit correct. And the last mark is to get 18 over 34 as your final answer.